Input validation, a brief overview by Jeff Johnson. There are two main types of input validation, syntax and semantic. Syntax validation means to check that the data is in a form that is expected by the application. An example of this would be an ID field that uses a 4-digit number. To verify the syntax, the program needs to check that what is entered is 4 digits in length and made up only of numbers. Semantic validation means to check that the data falls within a specified range based on functionality and context. An example of this would be to make sure that a start date is before an ending date. There are two common approaches for input validation, deny listing and allow listing. Here we see an example of a deny list that's populated with keywords that the application will look for. With deny listing, the form of validation attempts to check if the content trying to be passed in contains any known bad content. This helps to detect and potentially stop obvious attacks against the application. An example of this in action would be to block any input that contains the exact text of script, which could prevent cross-site scripting. This could be evaded, however, if the script tag is in lowercase or mixed case, as the list only looks for the exact text that it is supplied. Allow listing is a form of validation that attempts to check that the data matches a set of known good data. An example of allow list would be checking to make sure that a U.S. state is entered by the 2-letter code and that it is in fact a valid U.S. state. There are two forms that we can look at with both client-side and server-side validation. With client-side validation, it can be used to tell the user that their data does not meet the criteria. Websites often use JavaScript to display special colors or messages if the data the user is entering does not meet their standards, as represented by this picture. When we talk about server-side validation, we can think of it mostly from our standpoint of using if statements. It should always be performed for security purposes. Since there's ways to bypass client-side verifications, the server should ultimately get the final say about the data to ensure that it meets the criteria before being allowed to be passed into the database. You can also use regular expressions for validation purposes, and they can be used to check whether or not data matches specific patterns. In the example here, we can see that a username would consist of only letters, numbers, and the underscore character. It would also indicate that the username is limited between 3 and 16 characters. While regular expressions can be nice, they should be used with caution, as poorly designed expressions could result in REDOS, regular expression denial of service, similar to DDoS, in which the attacker exploits the fact that the expressions can cause the application to be pushed to extremes, which can bog it down or cause crashes. Regular expressions can also become very complex and difficult for other programmers to understand and maintain. There are limits to input validation, and while it's a good idea, there are still ways to get around. One example would be an email address verification. While the input validation clears an email address that was provided, as it sees a string of text similar to what we have here, text at text.text. However, one part of the email could contain a SQL injection attack. Another example would be a URL passed that could be verified, but it could contain cross-site scripting attacks. Additionally, some forms of input are so complex that validation can only minimally protect the application. One such complexity is the use of serialized data. While it's a good practice to encode your data as to not send in plain text over the web, it's dangerous to accept and deserialize data from sources that you don't know or trust. If a user is able to figure out how you serialize your data, they could reverse engineer the process and send the application their own set of data that looks like yours but contains malicious code. Another example lies with the use of auto-binding HTTP requests within the application. In this instance, the user could search through the code or application data, find areas that they can modify their access level, or they could circumvent the intended logic of the program. There are a few ways that this could be handled. One, Avoid binding the input directly. Instead, use a data transfer object and set up an allow list rules for each page to define which fields are allowed to be auto-bound. In the example here, we see that this form as well as the object contain a user ID, a password, an email, and in the object itself contains an isAdmin. Now with those auto-binding requests, as they're passed into the post, information is passed for the user ID, the password, and the email. However, that could be altered to change the isAdmin boolean from false to true, granting the user privileges they're not supposed to have. Ways to overcome this: all languages and most frameworks provide access to validation libraries or functions that can be used to validate the data. The libraries and functions cover common data types, length requirements, integer ranges, null checks, and more. These libraries help save the programmer time by not having to implement the checks themselves, but also allow them to create their own expressions or logic for extra security. Another added advantage is that the people that make these libraries often will go through their own tests to ensure that what they are passing to users works appropriately. Final thoughts when it comes to input validation is that it can be a powerful tool for programmers to ensure that the program functions the way that they want it to, so long as everything's used the way it's intended to. It does help provide extra security to certain forms of data, which can help prevent certain attacks. I like the analogy of comparing input validation to a suit of armor. The armor protects the wearer and limits the surface area that others have to access their vitals. It doesn't make the person impervious to attacks, but it protects them way more than wearing nothing. At the end of the day, though, most experts agree that while input validation is a good practice to get into, it should not be used as the primary method of security for your application or database. And of course, here are my list of sources. Thank you very much for your time.